Okay, good morning, everybody. This is Jesus Latova from Carlson EMEA. This webinar is going to be in relation to a couple of new features already started in 4.03. And let me advise you first that if you have any questions, you have a questions entry, so you can write your questions in the GoToWebinar panel on your right side, and we will try to attend at the end of this conference. Okay. So, well, first is to I would like to remark the importance of these two features in what is related to, the ultimate goals on any staking or storing points in the field is for seeking the point and finally match the point. Okay, so sorry, if storing points or making a point collection for creating a new map or something, the point is to be identified in the ground. When it is about stakeout, the point position is coming from design, so it's previously calculated. And at the end, we need to match the point. We need to, whenever we're running with GPS, we need to get the pole well center level. So this is the everyday in land surveying application in the field. So any improvement on this is really good, is very important. Okay. The ways to do that and how these new features will be coming are already running in SurvCE is that we try to find the best friendly graphic user interface for stakeout is one of the features, and for the pole centering and leveling. And we are trying to combine these new symbols in the graphics to have really visible guidance and indicators for approaching the point, leveling the pole, and doing this in a friendly manner and the quickest that possible. Okay. There are, of course, some of mathematical algorithms that we are working on to achieve good results from this. And this is a lot of things has been recoded in SurvCE to make this happen. In order to get the leveling functionality first, of course, we are using the tilt sensors on new receivers and IMU sensors in new receivers. I would say this is going to be really important this year. Okay, so almost every branch of GNSS receivers are coming with these new models, including sensors, right? So let me tell you that the first approach we did was on 4.03, and it is for our Carlson V5 receiver, and this is the one I will use today to show you. Right, the VRX5 by now is only including tilt sensors, so it's no more sensors like gyros or compasses or things like that. It's just tilt sensor that allow us to measure how tilted is the pole and in which directions relative to the instrument, so X and Y axis of the unit. Right, so it is important whenever you work with a receiver that only has tilt sensors like this one, you need to face the panel of the receiver, okay, as you can see in the picture, just to make the bubble motion match with the direction of the unit. Okay, this is something important to consider. Okay, so in these graphics you can see the two combined functionalities here. So you can see this bubble, moving bubble here. You will see later in real time. That is the blue and the red circles on screen. And two screen captures are showing the two different phases that we have done on this Stakeout guidance that is based on motion by now. Okay, so the first one, the one in the top, is related to the navigation to the point. It is from the time you are hundreds meters or kilometers or 10 meters away from the point, and we split the Stakeout in a second phase, that is when you get into what we call a proximity circle, and we change the interface to show us as the second screen capture below, where it is a more refined guidance to go back and forth for the left symbol, or left and right to approach the point and make the best match possible to the point. Okay. So what are the features that will be coming from this? Well, of course, the sensors in the unit require calibration, right? This is something we have learned, and all the users will be learning along this year. SurvCE has already included a calibration routine that I can show you later for the tilt sensors, very easy calibration. When it comes to more complex sets of sensors, the calibration routines are more complex, and because there are several devices that have to be calibrated. Talking about the features, we have the first is the electronic bubble showing in the screen, of course, and of course we have done, because of the sensor is providing readings, angular readings of the inclination, then we can play with tolerances, right? We'll talk about that later. Second thing is, well, a lot of new features will be coming based on this. We are working on those right now. They are not yet in 403, but I can just make a quick list of nice functionality, all of it to gain productivity and accuracy, because I think that is the main goal on these new features. So one could be auto store when level. You all know in SurvCE there we have this auto by interval that can be time, can be a distance, or will be a third option for leveling condition, right? So again, we have a leveling tolerance, so when this condition happens, then you don't need to even press the enter key or something, but for a quick survey, it would be really productive feature, okay? More features, well, in relation to accuracy, could be best center shot within an interval of time, still under the tolerance condition, think about we're probably working 5 Hertz and taking a lot of shots in the near to the vertical position, so maybe making an average or getting the best shots, the one that is closer to the vertical position. So things like that can be done and will be coming in version 5. Okay, version 5 of SurvCE is initially expected to happen end of May or June. Okay. So, well, I was saying auto store, best center shot, auto stake could be also a new function here, and of course, when it comes to receivers with a full set of sensors, IMU sensors, I would talk about the tilted pole measurement. Okay. We are working on tilted pole. We have done some implementation. We have started to experiment with this on the Stone XS10, and I tell you that is a really nice feature. Okay, we are refining. There's a lot of complexity in the code for think about we have to work on the on the coordinate transformations and a lot of things and a lot of I wouldn't call restrictions, but things to check for what is going on. We're using compasses, things like that. So checking for no magnetic interference is happening, checking for static conditions when measuring a few things that need to be very tested in the field and to refine it to make sure this is a reliable feature. Okay. But I tell you that well, everything is going really nice, and the feature for measuring on a tilted pole will be coming very soon. Okay. So in relation to Stakeout, there are new features that we will be seeing later. I will not list now, but we'll see on the next screens. So I don't know if, again, let me remind you, if you are having any questions, I don't think there is a lot of attendees for using this tool of raising hands where you could talk or something. We can later read your questions and try to answer, okay? So, well, let us start a bit on the Stakeout. I will split now the two features, starting by Stakeout 1. So let me go and run our simulator. This is not tied right now to a real GPS. Okay, I'm running SurvCE demo, and you can see here in the icon that this is a GPS simulation. Okay, the thing is, I have a real GPS here that I will show you later for the bubble thing, but my fixed position is from a re-radiated GPS signal, so I cannot move in the room because I always get the same position. So in order to explain the Stakeout, I can run simulator. So let's say, first of all, a thing is, what are the settings for the Stakeout? Okay. Write down about job settings. There is important one, job settings stake tab, that is the proximity radius. Okay, this, I'm not sure, you will probably get a default value of half a meter. I would suggest starting 1 meter, even 1.5 meters for this proximity radius that I will explain in the next screens. Okay, so this is important thing. Related to settings. Second setting is under Equipment Configure and View tab. Okay, here you have the proximity Stakeout. So this graphic guidance that I will explain you now, that is perfect compatible to whatever was before in SurvCE. So you can still run your favorite method for viewpoint. I suggest east, west, north, south, and I will tell you why later. Here we also have the toggle to view or not view the bubble. Okay, this electronic vial on screen. Okay, I'm not putting right now because I just want to focus on the Stakeout guidance. Okay, so of course these configure view settings you can find in the configure button under Stakeout as well. So you could come here and switch on and off this quickly, and there is no conflict with any of the previous methods in SurvCE for Stakeout, right? So let's go now for the Stakeout. I'm gonna stake a point. I only have 1 point here for this presentation, and I green check to stake out this point, okay? And I told you before, we are getting the Stakeout split in 2 parts, right? So the first one is the approach to the point, seeking the point, as I was mentioning at on starting the conference. So this phase is within any distance up to the proximity radius we have configured. This 1 meter proximity radius, okay? And the user interface is this big cursor that you can see here right now. And what it's telling me is my my drifting from approaching the point. So you see now that the triangle in the map is going to the right of the point. I'm not matching the point, so the big arrow is telling me, okay, you need to go left. Okay, so what we need to find here is the situation where the arrow is pointing to the top of the screen. Think about this is motion based. That means the graphic you're seeing right now for the big arrow is not related to north-south, is not related to the reference in the map below, but to your own motion, your heading, okay, where your face and your nose is pointed out all the time, okay? Right now, let me tell this. How we compute the heading is based on tracking the positions, right? We are working on reading the compass from not only the GPS receivers but also the data collectors. Many data collectors are including a compass, and this will even make it more reliable in version 5. But right now, think about if you're trying to use this, that you need to move, right? You need to move for you get a good heading. If you if you get here and see the directions in a static situation, it will be unresponsive. So it will be a wrong heading because you need to move. As soon as you move 1-2 meters, it will start working. Okay. So the next thing is I can see approximate distance, 0.4 kilometers when approaching the point right now. Okay, you normally are closer to the point. So let's go. I'm heading to the point. Of course, you can maximize the graphics. And here is, just to remind you, I see east north. Some of you will see coordinates here for east and north in elevation. I remind you to change that. Use the config button here, view, and on collapse report, select navigate data instead of position. That is, I think navigate data is more usable. And still I have this method. I was suggesting east, west, north, south because there are a few cases where our algorithm could break right now on computing the heading, is that there are obstacles in the middle, you know, and especially harming this routing when there is a car or something very close to the point and close to the proximity area. Because in that final phase, we need to fix your heading, you know, and you shouldn't be twisting around or changing your direction, or the routing would be, you know, less reliable on telling you the left-right guidances. So that's why keeping the east-north in the bottom could help in those few cases for, you know, still doing that point, completing that point, and by using the small compass in the pole. Of course, this in version 5, if you're using a receiver, let me stop here. I am close to 1 meter, but I want to stop before. But when we implement the compass readings in version 5, then you don't need to care. You can twist around. You can do anything because the heading, your heading is known at any time, even on a static situation. Okay. So look at this. Remember, we set 1 meter for our proximity. I am 1 meter and 5 millimeters. That means when I step into 1 meter cycle, the interface will change. But before going ahead, think about this. This heading we compute right now is based on the last track you did, like 3-4 meters before getting to the proximity cycle, right? So those 3-4 meters are important in the term of, you know, you should be, we assume you are heading to the point, at approaching the point, and not doing big changes in your trajectory, okay? So when we compute an average azimuth on approaching the point, and that is your reference for the final refinement of the point. So I'm going ahead and getting into the proximity cycle. You see how this changes. Oh, wait, I'm turning around. Sorry. Okay, coming in again. Okay, you see the interface is changing. The red dash cycle here is our proximity 1 meter. It is shown real size on the map scale. And you can also see a new symbol here that is the green dash cycle. That is our tolerance for stakeout, okay? The tolerance that you set under stakeout, let's go out and see, oh, okay, not now, I will show you later. So this is also real size, so we need to hit inside the green cycle to do this stakeout in the right tolerance. Okay, next thing is, you see this, oh, again, I'm going out, sorry. You see this, let's go inside for not, okay. Okay, well, I got a change in my fixed azimuth for entering here. So you see the black line, continuous line, is showing my heading to the point. Right now the routine failed because I was doing something that will not happen in the field normally, is that you're moving in and out all the time. Let me go out again and so we can recompute our approach to the point. So again, I'm going back like 3 meters would be enough and head to the point again. You see how the big arrow is telling us to go right now. So in the final approach, we are facing more or less facing the point. You know, it is not really drastic to be heading exactly, but okay. So getting into the proximity area, we are now. This is now telling me 79 centimeter. Okay, in the reality, how this works is that when you're approaching the point with a big arrow pointing you the direction and looking at the distance, then you almost visualize the area, small area where the point should be, okay? So what I suggest is to look at that point in the ground, that area, and try to hit with the pole direct where you think the point is, right? So it will take you to some position normally within this 1 meter area, okay? You could set it to 1.5 and to make it easier. And so, and I probably level up and see how I am in relation to my motion. So just in front of me, it is telling me to go ahead 66 centimeter and 9.5 centimeter to the left, because of this arrow is telling me left, okay? So this is the normal situation. Left and right is a very small correction. Why? Because on this average azimuth you were approaching to the point, you were almost aligned. So your final correction, and this is important, is normally only to be done on the back and forth, at least the big amount of it. Okay, so we make our first try with the pole in the ground and see, okay, it is like 66 centimeter in front of me and a bit correction to a small correction of 9 centimeter to the left. So I make my second try. I visualize in the ground these distances align with my face, let's say, just in front of me, one line 66 centimeter and 9 centimeter to the left. So I make my second approach, okay, I will be getting closer and I level up, and you know, with a bit of practice you will find that the second try is good enough at least to get into the tolerance cycle, okay? So your any approach you're doing, you're getting into and getting closer. You still have to correct 11 centimeter forward, 6 on the left. Look how moving left and right here is moving this black line parallel because it's my fixed azimuth. So you shouldn't twist right now or around the point because then your reference is lost, right? If you have any trouble, you always have any other this easing and northing, right? And in the future, when if you have available a compass in the unit, in the receiver or the data collector, this will be much more easier because we don't need to fix a reference based on motion, but knowing the head in real time. Okay. Look at this change. Now, instead of just a black arrow, it is showing this this kind of diamond. Okay. So this means we are inside tolerance right now. So we could put a stake right now and believe in this. We are within tolerance. Still, of course, you can refine. This tool can be used in robotics. In robotics, you can make a match, a perfect match, to go to the center in the range of 1 millimeter, let's call it. So a total station is easy to find that situation, and if not in GPS maybe, but with a total station you could really make this cross fit in the center symbol, and that would be showing the diamond black, fully black. Okay, let's say, okay, you're matching the point perfect. Okay, so well, this is about the navigation. Let me check what is in the list here. Okay, again, remind you, questions, write it. You can write them right now, and we can try to answer at the end of this conference. So let's go now for LDL, so this live digital leveling feature. Okay, so going ahead, we change to real simulator. Okay, first about settings for leveling. So let me show you. Now this is real. I'm connected to our Surveyor 2 data collector, which is connected to a VRX5 receiver. So checking into tolerances, here you can see the level tolerance. This is the new. The leveling tolerance, you set it in meters, linear units. Okay. My setting is 2 centimeters. This means my tolerance for deviation from the vertical. I mean the phase center deviated from the vertical of the line of the ground position is set to a maximum of 2 centimeters right now. Okay. This calibration is, I will explain now, this is a beta version with things that we're working on for calibration of the sensors. So this is set on in meter, and of course, it depends on the antenna height, right? Because at the end, tilt angle will compute a final linear deviation that is different depending on the antenna height. But you don't need to take care of that. So green check here, this is my limit, 2 centimeters, okay? I tell you, with a 2 meters pole, 2 centimeter is something realistic, I would say. Below 2 centimeters, it's really hard to make it match and keep it vertical by using a hand, okay? Unless you're using a bipod or a tripod or something like that. Anyway, let's say 2 centimeters for this case. Important is, of course, that we are setting a good antenna height, okay, to make for this tolerance can work fine, okay, because here we are getting now real-time readings of the tilt sensor, so we are getting the bubble moving. The black circle here is we could say the viewer of the vial, okay, it's fixed. The blue line is the bubble, as you understand the bubble in a physical vial, and the internal circle that is showing green right now is the tolerance vial. Okay, so next is, well, if I tilt a bit, I have my receiver in the tri-bracch in the desk. You can see it is moving, it is going out, it is coming in. Let me explain you a bit. Oh, well, this is a graphic I missed to show you. You can see here for the Stakeout the proximity area concept set to 1 meter, this red area here, the 4 meter approach for the final average of a final heading. Okay, anyone interested could write me after this meeting, and I could copy you this presentation. Okay. So these are this is the layout for what the symbology means on the leveling. Okay, so you have three cases. You have the best leveling, that is when the blue circle is fitting good in the viewer and showing this band to be regular around. Okay. Second one is when intolerance. Of course, the first is intolerance as well. It is the very best leveling. Second one is not perfect level, but intolerance. We can identify this for the small circle inside is showing green, or is inside the viewer, all of it inside the viewer, not caught in the viewer or outside the viewer, but inside. Okay. Whenever the bubble is moving out and the internal circle is cutting the viewer, it will be switching to red and warning us. Okay. So second thing for the tolerance is, if I try to store a point when the out of tolerance condition is there, I will get a warning like you get it with the RTK fix filter, like saying, hey, you are out of tolerance. Do you really want to store the point? And then you can decide if doing or not doing. Okay. So going ahead, back to the simulator. Okay. I'm moving here. I think I could show you with a camera. I will take, okay, hopefully you can see me here. This is the V5. You guys can see a small window showing with the camera, my ugly face there, the receiver. You can increase the size of the window. If you're seeing that very small, you can pull from the down right corner. Okay, so let me show you the reactions. I will change a bit because holding my hand is quite difficult. Let me tell you, I can change the sensibility now in the simulation by just putting a very low antenna height. So my 2 centimeters on a short distance of half a meter are automatically making my vial less sensitive to the motion, as you can understand. So if I try to bring, okay, let me do, I have to put a panel in front of me to understand the left and right motion of the bubble, right? So now it's easy for me. You see, I'm putting in tolerance, and I know where I have to tilt to the unit to get inside the tolerance, right? Or if I am tilting this to this side, this is going out, and even there is a situation where the inner cycle is dropping, is going away. That means I am out of range to show in the screen. It is not that the tilt is not working. Yes, it is still working, the tilt sensors, but it is telling me still where I need to pull or push my pole to bring it right to the center. Okay, you know, there are situations, you know, in the field, if you are not in a horizontal place where you don't really know where the vertical line is, so it will always tell you how to bring the bubble back to the center. Okay, so this is a bit a situation. So, well, this is simple. If, you know, on any case, if the bubble here is annoying you, you can always go to the config button here and switch off the view GNSS level, and it should still be filtering for the out of level condition. You see, I don't see the bubble. I could do an approach maybe with the vial in the pole, but still I have this control for the leveling going in the background and telling me, hey, your level tolerance of 20 millimeters, we should put the units here, 2 centimeters or 20 millimeters has been exceeded because I am now 101 millimeters away. So would you like to continue? Okay, I say no, I don't want. So, well, this is the basics. This is what is done right now, only in the VRX5 unit in version 403. But of course, you guys are using many other different receivers, and everything is coming. We have several programmers working on the different units. Let me show you. We are working on, well, the StoneX stand, which has a full set of sensors. This is a special tool they have for doing the calibration, okay, because it has two compasses, I guess. So, calibration procedure is a bit more complex than only tilt calibration that we have by now set in SurvCE. We're also working the CHC I-80 is same kind of full sensors for compass, for direction, for everything. The FOIF 820 unit we're doing on a Spectra unit as well. So I would say all of the brands or most of them will be coming with a solution this year, and we are working on for all of them. Okay. Just to finalize, I think this is taking too long. Let me show you very quickly how to perform a tilt calibration. So let's go on this same unit, VRX5, go Equipment, GPS Utilities. You will all find this GNSS level calibration for VRX5 or IMU calibration for others or whatever. There will be different features. Even we are doing a one-point check to prove the calibration is good on tilted poles. All those features will be coming version 5, already working for some units like the StoneX ST, but doing the final refinements. Okay, so let's go to level calibration. We have zero calibration is not very good, I would say, because you need to be in a horizontal place. So we're probably hiding and showing only the auto calibration. So the auto calibration you could do on a tri-brush, or you could do on a. I suggest to use the same pole that you are using in the field, and you know how to calibrate a vial in the pole, like holding against a corner or something almost vertical and twisting 180 degrees. So this is more or less the process. Okay, so these are the real-time readings for the two sensors X and Y. This is degrees, and it is telling me to set the units in the first position. Okay, let me block this a bit. You don't need to be perfect horizontal, okay? You know, when you calibrate a level, you don't need to. So this is the same case, right? So I fix this position, and don't touch my table because there shouldn't be vibrations during calibration. We have a filter, so if you touch or move the pole or whatever during the averaging, you will be, the calibration will be voided. So start phase 1, and in the phase 1 what we do is to take 30 readings of the sensor in this position. Wait for that. You see the angles. I'm not really horizontal. I can see the bubble in the tri-brush that is partially out of the reference line. So now it is telling you to rotate the receiver 180 degrees. So I do that and come to the opposite direction. I wait a bit to, for sensors get stable and quiet, and start phase 2. You see, I got an average reading from this 30. This standard deviation is reading the noise. If the noise is too high, it will be stopping you and telling you to repeat again. That because of interference, noise, vibrations, you are touching. So we start the second phase of the calibration. Again, 30 readings in this second trial. You see 0.2 degrees, 0.3. Well, and at the end, we get a final report. Sorry, because running the SurvCE demo in this resolution is not showing the last line. It will show in your computer, but I can explain you. Okay, so I got the phase 1 average standard deviation, phase 2 average standard deviation, sensor error. You see, it is quite good calibrated. I'm getting this error in the two sensors, like 1 millidegree and 3. And the bottom line is telling me how much that is in meters at the antenna height of 2 meters, okay? And it will be showing probably less than 3 millimeters or something like that. You know what I consider is good. If you consider is good, then you can exit and don't apply calibration. Or if you want, then you apply calibrations, and these errors will be set in the firmware, in the unit, for later refined readings of the sensor. Okay, so well, that's all about the sensor calibration. I think we have run all. As I told you, a lot of new features will be coming based on only the tilt sensor, and a lot of features like the measuring on a pole, a tilted pole, that I tell you will be a fantastic feature for productivity, for accuracy, that will be coming very soon now. Okay, so guys, I don't know if you have any questions. I will still stay here for 30 seconds or 1 minute. This was a bit long, but just let me know. Okay, let me ask Zlatko, do you get any questions?
Well,
okay,
I can answer for that. It's Thomas here speaking. We have now, right now, 5 questions. So I don't know, Jesus, if you can see them. But probably we are a little limited in the time, so we will. You can try answering these questions, but anyway, we will keep them tracked and we will answer per email to your individually, or we can send an email to all the group.
Okay. I can hardly see the questions for any reason. I can see one that if Hemisphere S320 as well. Yeah, same like Real X5, or everything we have shown will be there. Okay, guys, listen, I will read carefully your questions. This was a bit long, so okay. Thank you very much for your attendance. I will answer, or we will answer these questions email. We have your emails from joining the conference. So, well, I do appreciate a lot your listening on this, and well, you can email any of us in Carlson MEA, and we'll be very pleased to attend your later questions. So thank you very much, and bye-bye.